So we know that in order to evaluate the joint probability of n random variables, x1, x2, all the way to xn, we can write down the product from I equals 1 to n of the probability of each of them, given that they're independent. Now recall that the last time we used this, we were dealing with events, but again, an event is just the realization of random variables. So whenever you write down x equals something, that's an event. In our coin toss example, if you wrote down x equals 2, then that's the event in which we get tails 2 times in the 3 coin tosses. So notice also that he used the comma for the intersection when dealing with random variables, and that if you have 2 random variables that are independent, this means that the realization of one of them does not affect the probability of the other. So we know how to do this if they're independent, but how about if they're not independent? So we're looking for the product x1, x2, all the way to xn, given that these events are not independent. For this, we'll have to use the chain rule. And I'm going to start by writing down the chain rule for 2 events, so the probability of x2 and x1 happening. That's going to be the probability of x2 happening given x1 multiplied by the probability of x1 happening. And this directly follows from the formula for conditional probability. So before showing you the formula for the chain rule, which is just right here, let me take this down. Let us try to do it on 4 random variables. So here we have 4 random variables, x4, x3, x2, and x1. And we know that these are not independent, so we're just going to try to continuously apply the chain rule and see what do we come up with. Okay, so I'm going to start by writing down p of x4 given all else, so x3 and x2 and x1, and then multiply that by the probability of x3 and x2 and x1. And then I'm going to apply the chain rule again here, so we're going to have p of x3 given x2 and x1 multiplied by the probability of x2 and x1, and then again I'm going to apply the chain rule here, so probability of x2 given x1, and then multiply that by probability of x1, and here this is a dead end, so this is all we can do to evaluate this thing using the chain rule. Now if we look at what's happening, that's a product, so we can start by writing down a product here, and if we have 4 random variables, we multiply 4 times, so I can go from I equals 1 to n, and here I'm having 1, 2, 3, 4, so that's the probability of xi given all that precedes xi. So I'm gonna put down here x1, x2, all the way to xi minus 1. And this is gonna be our formula for the chain rule for n variables. Now, this is gonna be a quick application on the chain rule. And here we presented this Venn diagram with this being x, where x is an event. And again, an event is just a realization of a random variable, so this means that we put x as something here and y as something, because all of these are actually events, okay? Just so we can represent them using Venn diagrams. Now here x is the circle, and as you can see it has intersections with y1, y2, and y3. So this is y3, this is y2, and this is y1. And what we need to do is find the probability of x happening with knowledge of only the probability of x given yi happens and the probability of yi happening. So what I'm going to start writing down is that the probability of x is going to be equal to the probability of the intersection of x with y1 plus the intersection of x with y2 plus the intersection of x with y3. Because if we add these three intersections, we do actually get x. And then I'm going to use the chain rule on each of these. So here I'm going to have the probability of x given y1 multiplied by the probability of y1 plus the probability of x given y2 multiplied by the probability of y2 plus the probability of x given y3 multiplied by the probability of y3. In summation notation, we're going to go from I equals 1 to 3, and we're going to have the probability of x given yi multiplied by the probability of yi. Now, let's say we had n classes instead of just 3. The summation is going to become from I equals 1 to n of p of x given yi multiplied by the probability of yi. And this is all we needed to do for this problem. So thank you for watching.